Hey everyone, welcome to this video. In this video, we'll be talking about the types of data. Now, the first thing is that if let's take an example, a column of numbers. If you're finding standard deviation, mean, median, mode, you're finding the distribution curve, and if that column is a serial number column, then there is no point in doing that. So before getting your hands dirt on statistics, you need to know and understand the types of data you're going to work with. So let's talk about the classifications of various types of data. First thing, based on nature of data, it can be classified as numerical and categorical. Categorical data generally refers to the names, or it just describes the quality of the data. On the other hand, we have numerical data. If we can quantify the data, then it is known as numerical. It usually represents the quantity. Okay. The numerical data can be further classified into discrete and continuous. To understand this, let me give an example. Okay. Let's assume that your dad is asking you to buy some milk. You have two options. First option is that you can buy packets of milk, or else you can buy directly from the milkman. Okay, let me draw a scale to measure the quantity of milk you're going to buy. Okay, so let's assume the minimum denomination of milk packet you could buy is 0.5 liters. So the various options you are available for you to buy milk is that you can buy 0.5 liters packet, or you can buy 2.5 liters packet, which sums up to 1 liter, or you could buy 1.5 liter, or you could buy 2 liters. Okay, now the question is, if I ask you to which kind of data these data points belong to, we generally tend to answer it as it comes under continuous data. Just because we see some number which has decimal in it, we usually tend to believe that it belongs to continuous data. But these data points belongs to discrete. I'll tell you why. Because in none of these data points, you can buy 1.6742 liters. Is that possible to buy? No. You can only buy milk packets which are multiples of 0.5. You cannot buy other than that. So here, the values which are not in the interval between these numbers are not possible to buy. So such data points are generally referred to as discrete. Okay, now let's take the second example. If you are directly going to a milkman and buying, if he's having some precise instruments which can measure the exact quantity of milk, you can even buy like 1.7642 liters, which is not even in this scale. It is between 1.5 and 2. So it is in between the interval of 1.5 and 2. So this type of data points are known as continuous. So if there is a possibility of having a data within an interval, then it belongs to continuous data. And if only certain points, discrete points with equal intervals between them are possible, then it comes under discrete data points. Yeah, so that's all about continuous and discrete. Now let's come to based on time of observation. Time series data. Yeah, it's a fancy word on data science project on weather forecasting. So what is time series data? Like for example, if you are considering the weather on a particular day in Delhi, like for example, if on 22nd of July, if you want to know the weather of Delhi, for 22nd of July, then for every hour, there will be some minute changes in the weather. So the entity on which we are measuring remains the same. Here the case is Delhi, but the time on which the observation is made differs. Like we will make an measurement of the weather on morning 10 a.m., on afternoon 12, on evening 5 o'clock, on a night 10 o'clock. So here the entity remains the same, but the time of observation varies. Such kind of data points are referred to as time series data. Whereas in cross-sectional data, let's assume you are calculating the let's say same example. You are calculating the weather on different cities at the same time. Here the entity varies, Delhi, Bombay, Chennai, but the time of observation of the weather remains the same. Such kind of data belongs to cross-sectional data. So the main difference between them is in time series the entity remains same but the time varies, whereas in cross-sectional the time remains the same but the entity varies. Now comes the main classification based on their behavior. It can be classified into nominal, ordinal, interval, and ratio. Here, nominal and ordinal belongs to the categorical data, whereas interval and ratio belongs to the numerical data. Let's see about nominal. Yeah, these kind of data doesn't have hierarchy. It is an important point to remember. This kind of data doesn't have any hierarchy. Hierarchy means it doesn't have any order between them. Let's take an example of the days of the week: Monday, Tuesday, Wednesday. Like Monday is in no way greater than Tuesday, which is in no way lesser than Wednesday. All are equal. So the kinds of data which doesn't have any hierarchy between them are known as nominal. As these nominal belongs to the categorical data, they can't be compared, or performing arithmetic operations on them is totally meaningless because they simply consist of words. So here, computing central tendency values, which means mean, median, mode, or any arithmetic operation is meaningless. Now let's come to the second category, ordinal. This also belongs to the categorical variable. But the point is that it has hierarchy between them, which means it has certain kind of order between them. The best example is that the rating given to a hotel. It can be good, bad, or worst. You have a kind of hierarchy between them, so the comparisons is possible. But still, you cannot quantify that. So again, performing arithmetic operations on these kind of data is pointless. But the main difference is that in nominal, it has a order between them, and in nominal, it doesn't have any hierarchy between them, but in ordinal, it has some hierarchy between them. Next comes interval. It belongs to the numerical category. So obviously, it is going to consist of numbers. So performing arithmetic operations makes complete sense here. They are meaningful, which means you can add or subtract. And also the numerical data points here has a fixed unit of difference. Okay, let me explain with an example. Let's take an axis. This is y-axis and this is x-axis. This is 1, this is 2, this is 3, this is 4. Sorry, this is -1, it's -2, it's -3. Okay, now let's assume you are standing at 1. You are A. Your close friend is standing at 3, B, and maybe your dad is standing at -2, C. Here the numbers, it is measured through form of numbers. The distance between A and B and C and A is measured through the form of numbers. So it is an interval variable. Here arithmetic operations are meaningful, which means what is the distance between A and C? To find the distance between A and C, we have to calculate it like 1 minus of -2, which means 3. Yeah, 3 is the difference between the position of A and C. Also here, the difference between 2 and 1 and 3 and 2 is constant. So it has fixed unit of difference. So such kind of data usually refers to interval. Now let's get to ratio. Let's have the same example. You're standing at A and your friend is standing on B at the position of 3, and your another friend is standing at C on the position of -2. Now, if we calculate the distance between A and B, it is 1. A and B is 1. Let's consider meters. The distance between A and C is 3. Now, if we consider the displacement between A and B, because displacement considers the direction, So I'm putting a vector symbol above that, A and B. Then it is 2 kilometers, 2 meters. But if we consider the distance between A and C, it is minus 3 meters. Okay. Yes. Okay. So the ratio has all the properties same to that of interval, which means arithmetic operations make sense here. We can add, we can subtract, and also it has a fixed unit of difference. But what differentiates between interval and ratio? The only difference is that interval doesn't have a defined starting point, whereas ratio has a defined starting point. I will explain you how. Like for example, what is the range of displacement? It could be anywhere from minus infinity to plus infinity. But if you consider the distance, it can only be from 0 to infinity, because distance cannot be negative. So in the case of displacement, we do not have a defined zero starting point, but in the case of distance, we have a defined zero starting point. So okay, keep it apart. Now let's come to the same case, AB and AC distance. Now if someone asks, okay, tell me the ratio of the distance between AB to that of AC, then I can easily calculate it as B is AB divided by AC, which means 1/3 times nearer to A than C. As I am considering the distance, I can just find the ratio, which is 1/3. Whereas if someone is asking what is the displacement ratio between B and C, it is totally meaningless to calculate it as minus 3/2, because negative ratio doesn't make any sense at all. So the important thing to remember is that even though addition and subtraction makes sense in interval, multiplication and division doesn't make sense. Whereas in ratio, as it has a defined starting point or a defined zero, multiplication and division makes complete sense in ratio. Another famous example for interval is that temperature. You cannot define absolute zero temperature. And many examples for ratio is marks, speed. All these things start from zero. They have a defined starting point. And also multiplication and division makes sense in ratio. So that's all about the types of data. Thanks for watching. Subscribe to Sigma and keep an eye out for the new content. I'll see you soon.